We need a wire. Oh, can you see the electrons flowing through the circuit?
Yeah.
Yes, sir.
Okay, so the bulb is glowing. Uh, because electrons are flowing from the negative terminal of the battery. Like this is the battery. This side, the left side is negative terminal. Positive terminal is on the right side. The electrons are flowing. Can you see the electrons actually flowing?
Yes, sir.
Yeah, so it's flowing starting from the battery, going into the bulb, and the bulb is glowing, and then coming back to the battery. Okay. If I want to make the bulb glow brighter, so I need to increase the potential of the battery. Let's make it more.
That increases the speed also.
Yeah, that's what can you see the electrons are flowing faster
Yes, sir.
Yes,
Yes, sir.
sir.
and the bulb is glowing brighter?
Yeah.
Yes, sir.
Yeah, that makes some sense. So that's what battery is doing. It's just increasing. It's like when you're increasing the potential of the battery, it's like it's catching the ball fast and like catching an electron from one end and throwing it to the other and faster. That's what
Sir.
increasing the potential of the battery means, right?
Yes, sir.
Uh, okay, but now how do I stop it?
Just take off a wire.
We need to
Okay,
break the circuit.
we need to break the circuit. Okay. No, but I want to I cannot keep breaking the circuit again and on.
We
So
can use a switch.
Yes,
let's
sir. We
use
need to
this.
off the switch.
Let's use a switch. Yeah, that's a good idea. So that we don't have to break the circuit all the time. Bending the wire doesn't matter. Yeah, we can because now we have a switch here. The switch is connected and the bulb is glowing. When we want to switch it off, we'll just break the circuit. Simple. Just putting the values here also. The the resistance of the bulb is 10 ohm and the potential of the battery is 20 volt. I want to know how much current is passing through this bulb. For that, we need an ammeter, I guess. Okay, this is my ammeter. I'll place the ammeter somewhere here on the wire. It will detect. How much is the current, Ryan?
2 ammeter.
2 ampere.
2 ampere.
Ampere. Ampere.
Yes.
Okay. If I increase the potential to 40, I double the potential. What happens to the current?
It
It in,
goes faster. It increases.
it
Increases.
increases. We can clearly see that the current is increasing to 4 ampere. Okay. So now we have, okay, if you see the circuit diagram, it looks like this: a battery, and then it's connected to one register, two registers. My pointer, the mouse pointer is visible to you, right?
Yeah, yes, sir.
Yes, sir.
Okay. So the first register and the second register, and then it comes through the key and then goes into the goes back
Battery.
to the battery. Okay, this is the actual diagram. Now we have total potential is 40 volt, and there are two equal bulbs here of equal strength,
10 ohms.
10 ohms and 10 ohms. So the potential, the battery, the total potential the battery is applying, it gets divided equally into the two bulbs because both are equal 10 10. So what will be the potential drop across bulb 1? What will be the potential difference across the bulb, the first bulb, the left bulb? We'll need a voltmeter. We'll put one end here and one end here. Oh, sorry. The bulb is not glowing only. So we'll plug the switch. What is the reading of the potential meter?
20.
So the total potential of the battery, what is the total capacity of a battery?
40 volts.
40 volt.
44.
And it is dividing the potential between the, if I check the potential here across the bulb, this is 6.67. This bulb is 16. And since this bulb and this pencil is same, even here it will be 16. We can check that potential there. Okay, that is also 16.67, correct?
Yes, sir.
Yes, sir.
Others wanted a short circuit. How to do a short circuit?
Connect off both the wires without the bulb.
Yeah, we'll do a short circuit. We'll remove all this. Did you see
Okay.
what happened?
Caught
Yeah.
fire.
Okay, the battery. Okay, the battery is on fire. Luckily, it's a imaginary battery. It's like a pseudo battery. Otherwise, we'll all have to run now.
Fire's not a joke.
And can you see that electron is just running through like rapidly?
Yeah.
Yes.
That is what short circuit means. Like you give now here we have a battery. Can you see? There's a battery, and then the current is starting from the battery, and it is as it reaches this point. If you can see here, just reduce the battery a bit. Potential. Make it little slow. Okay. Now, can you see that there's this is a battery from which electron is coming out, and it's going to the left, and then the stop here, and here it's splitting into two sections. Can you see my arrows, like my pointer?
Yeah,
Yes.
yeah, yeah.
So here it's splitting into two. Can you see if you observe the electron one by one? One electron goes up, one comes down. One goes up, one comes down. One goes up, one comes down.
Yeah.
Correct?
Yeah, yes, sir.
Yes,
So
sir.
it is because both the channels, like if you go through the upper path or the lower path, there's 10 ohm, 10 ohm resistance. Both has 10 ohm, 10 ohm. So both the paths are equally difficult to go. So half the electron is going in the upper path and half the electron is coming in the lower path. This type of connection of bulb is called as parallel connection. So a lot of you still think that parallel is like when the line is parallel. No, it's not parallel. It's when the current from the battery divides into two parts. Am I clear?
Yes, sir.
The line
Yes.
doesn't need to be parallel. Okay.
Like, I have a doubt, sir. Like, will the current, like, flow of current ampere change? Like, one goes down and one goes up, right, at that point?
Yeah, the current will change. No, see, suppose here two electrons are going in 1 second. In the top wire, one electron will go in 1 second. I'll show you with the ammeter.